Hi, boys and girls. All right, before you do your Google form for today's lesson, I want to give you a few notes that will make your Google form super duper easy. All right, the first thing is you're going to have to, on your Google form, tell Newton's first, second, and third laws of motion. So having the notes handy might make that really easy for you. All right, if you're really comfortable with it, I don't mind if you skip this part, but if you're not sure what to write, make sure you come back and hit up this video and write down some notes so that you can complete your Google form accurately. All right, Newton's first law is, see if you can remember, an object, yep, you can do it, an object at rest remains at rest until a force is applied. And likewise, an object in motion remains in motion until a force is applied. And remember, Newton's first law is the law of inertia. They're literally the same thing. The tendency to keep doing what they're already doing. All right, remember Newton's second law is all about force equals mass times acceleration, or FOMA, if you write it like a grown up physics scholar. Force equals mass times acceleration. Remember, when you get to higher math, you don't have to use a multiplication symbol. All you do is put your two variables together, right? And that signals multiplication. So F, force equals mass times acceleration. But remember, the simple way of thinking about this, in the way that you really probably already have a good handle on this concept, is that when something is more massive, it requires more force to accelerate. Which means, remember that accelerate is the tricky concept, that accelerate is any change in velocity. So that means any change in speed or any change in direction, which means starting and stopping, increasing speed, changing directions, etc., etc. So something more massive requires more force to accelerate, and then likewise, something less massive requires less force to accelerate. Newton's third law is the one we just studied, and it is the one about for every action, there's an equal and opposite reaction. All right, now in your Google form, you also have to put in some examples, and you have to do multiple choice to tell the examples and which one they are. A couple of examples of Newton's first law would be the penny experiment that we did, where you apply the force to the card so that the penny doesn't have force applied to it, so it stays put, but when you remove the card, gravity pulls it down. Another one would be the tablecloth one. So I'll write down penny and tablecloth. But then also remember how I talked about a car accident and how if you're driving along and the person who is driving applies the brakes, that you're only applying force to the car, right? So you're stopping the car, but you in the car have not had the braking force applied to you, so you are going to keep doing what you were doing. That's the law of inertia. When you hit the brakes on the car, there's no brakes on you, which is why you wear a seatbelt to hold yourself in, right? So if you don't wear your seatbelt, you're going to go flying and hit the windshield. That is an example of Newton's first law, the law of inertia. You want to keep on moving, but the car has stopped. All right, Newton's second law examples. These kinds of examples are all about when you have something that's more massive or less massive, that you have to apply more or less force to start it or stop it. So, for instance, if you guys were outside and you were playing and you couldn't find any ball but a bowling ball, right? You would greatly have to adjust your soccer game in order to be able to play soccer with a bowling ball. Probably would result in some broken bones and stuff, so you probably would never do that. But something more massive requires more force. So different masses of balls would be a good example, and the amount of force applied to each one. All right, and that should give you enough information to help you with this section of your Google form. And then the last one are some examples of Newton's third law. And I thought I would show you a little video for that one. All right, where'd it go? No, there it is, right there. All right, let's watch that for a second.
Of Newton's third law of motion, that states that for every action there is an equal and opposite reaction. The skateboarder, in order to do the kickflip over the bench, needs to first have his force go downward in order to pop the board upward.
Equal and opposite. He pushed down and the board went up.
The jet moves forward because the force of the engine goes backwards.
Ooh, think about that. Anytime you've seen a jet airplane go flying through the air, you've seen the white trails of condensation behind them, right? They go the opposite way. The force goes back and it goes the other way. And even a rockets, you see that the rocket fuel and the exhaust is pushing down, which is what makes the rocket go back up. Equal and opposite reaction.
Look at these ladies paddling. They paddle backwards in order to go forward.
Look at that. Equal and opposite.
This basketball bounces upward because it first goes down and the basketball court gives a force upward, which causes it to bounce.
Now, when you are doing your Google form, think about this one to help you with that question, right? Because I have one in there about a bouncing ball. When the ball is bouncing, right, it comes back with equal and opposite force.
Look carefully at this jellyfish. In order to move forward, it moves its body backwards, and the water has an opposite reaction and forces the jellyfish forward. Jumping on a trampoline is the same way. The force is downward, and then you have an equal force upward, which causes you to go up. And finally, look at this balloon. When the balloon hits the earth, it has an opposite force, which causes it to change direction and go upward.
All right, those are some great examples of Newton's third law. And now I feel like you will have no trouble at all with your Google form. So just check back in here, write it down, or just switch between tabs. I don't really care, but you should have an easy time doing your Google form, and I'll be so proud of you. All right, that's it for today and Tuesday. Love y'all. Be safe.